Hi, I'm going to explain about VLSI Design Flow. VLSI Design Flow is used to design mobile chips or any chips. We can design any electronic chips like laptop chips, or like computer chips, uh, computer chips, all the chips, military applications chips used in cars, etc. All the chips we can design by using VLSI Design Flow. So I will explain how you can design. These are the applications used in mobiles, used in pen drives to design pen drive. We are going to use VLSI Design Flow used in computers, laptops, tablets, washing machine, missile technology, or else even if it is drone technology, everywhere the flow is required. Design flow. How they are designing chips, that is VLSI design flow. I'll explain. Here you can see this. Here one idea is there. For that we need to design a chip. We need to design a chip. So then, for example, here I need to design a AND gate. Simple. Originally, if you want to design a mobile, we need to design a mobile phone with VLSI design flow. I will explain anyhow. So here, if we want to design an AND gate, we don't know what is the architecture first. We don't know what is the architecture first. So here, that is an idea. AND gate need to design. So here we need to mention the second step. They need to mention the specifications. What are the input and output specifications? So for that, so if you go for AND gate if you want to design, so then AND gate inputs are A comma B and the outputs are C. Outputs are C. This is the first steps in VLSI design flow. Then design an architecture. So we know that AND gate architecture you should design. For example, if you want to design RAM architecture we need to design. If you want to design pen drive architecture we need to design. So that is the flow. So in the second step, so this is an AND gate output. So here for this AND gate we need to design RTL code, register transfer level code we need to write. So for example, I am taking the same example. So here, here here we need to write the code for that. We need to write the code for that. That is Verilog code. For example, assign C equal A and B. C equal A and B. Here we need to write. So if it is verified without any errors, then they are going for PD. So PD means that is again it is the process. I will explain anyhow. So then they are going for chip designing. Then they are going for that is here we can say this without any errors if it is executed. So then they are going for that is verification and synthesis. Once it is executed, so then they are going for foundry to design a chip. So this is the flow to design anything. So I will explain the designing process here, how they are designing. I will explain here. You can see this. So the design flow is classified into front end process as well as back end process. Front end as well as back end process. Back end. So in front end process, as you discussed, the same step Same steps here. If you want to design anything, either RAM or ROM or anything, so for that we need to mention the specifications. What are the specifications? Input output specifications we need to mention here. For example, as I said, if you indicate inputs are, that is A and B, and the output is C. C is an output. If you want to take small example, A and B. So this is an AND gate designing, just assumption, but actually these are the basic gates already they are designed. So we can take directly either RAM or ROM chips or AND gates. So these are already predefined. So then we need to design an architecture for that AND gate. So then we need to write the RTL code as you discussed for that. RTL code for AND gate, just assumption we need to write. Then verification, RTL verification, code verification we need to go. If it is executed without any errors, so we need to go for PD, physical design. This is called as front end process. This total verification process is called as front end process. Generally, they are going to use very long to go for verification. Then in backend process, they are going to design, that is floor plan. Floor plan they are going to design. In floor plan, so for example, if you want to design any chip, there are different floor plans are there, like square shape, like triangular or rectangle or T shape, T shape, the chip size like this, or else L shape like this. So this is the floor plans. So we need to select depends on our requirement. Then they are going for, that is placement. We need to place the components here properly. So then only the speed will be increased or else power consumption will be decreased. Depends on our requirement. If it is a mobile, so where you keep the RAM, where you keep the ROM, where you keep the ALU. Like this, the placement will reduce the power consumption as well as everything. Then they are going for routing. So routing is best, routing is also gives the results, the power consumption will reduce and the speed will be increased. The connection between two devices, if it is a mobile, the connection between RAM to ROM, connection between IL to RAM, like this. So that is the connections routing. So after routing, if it is executed without any violations, then they are going for, that is foundry, means chip designing. Then they are going for foundry. So means here they will design the chips finally. Of course, after chip designing, again they will go for validation and checking. Again testing, they will go whether it is working or not properly. So this process is called as back-end process. This is an back-end process. Like this, we can design any chip in VLSI designing process. If you have any doubts, please send to me. Thank you.